yesterday, you really could do these problems without me helping you. I'm going to do one with you. I'm going to give you 5 minutes to finish it up. So it says, so remember yesterday we were dealing with square root functions and cube root functions? And we know that we can go ahead and calculate a bunch of values with square root functions and cube root functions. So on number 10, it says, if you know the area A of a circle, you can use the equation R is equal to the square root of A divided by pi to find the radius. So the first thing you've got to look at is, what are we given here? We're given an equation, right? We were told that that was the equation for radius, which makes sense. R is equal to. And then we have the square root of A divided by pi, where A stands for area. So it says graph the equation. Well, A or X, same thing, right? It's a variable, right? So really that's just R is equal to the square root of X divided by pi. You can just graph it by putting it in your graphing calculator. Go to y equals, type in the square root of X divided by pi, because a variable is a variable. If you do that, you're just going to y equals and graphing it. If you graph the function, it's just a square root function, looks something like this. I only need a rough sketch, I don't need a perfect sketch. Hey, listen. Okay? So, does everybody understand that A is just like having an X? Pi is not a variable, right? Pi is a number, so we're just graphing the square root function, we can use our calculator. A rough sketch is good enough. So it says, what is the radius when the area is 350 feet squared? So remember, the feet squared is just the measurements, the units of measurements. It says, what's the radius when area is 350? So aren't we just plugging in the area is 350? Yeah. So we have R is equal to the square root of 350 divided by pi. And then we'll just type it into our calculator. 3.14. No, don't type in pi 3.14. Type in the pi key, so you're exact. So do the square root of 350. It's got to stay in parentheses, divided by pi, close your parentheses. Because pi is underneath the radical. What do you get? 10.5, right? 10.56. So we really have 10.6. So guess what? Our radius, you guys, is 10.6. So, guys, these problems you're going to see on ACT tests, on end-of-level tests. It wasn't hard, right? You just had to look at it and say, what am I given? And put it in where you know. Okay, questions? Okay, I'm going to give you 5 minutes to finish up the worksheet handed in. 23 through 25. You're finishing it up and handing it in from yesterday. Okay, moving on. So to today's lesson, here we go. If you need more help, you'll have to ask in a second. So moving on to today's lesson. Are we all ready for that? Okay, so, guys, okay, so this is the unit of other functions. So 2 days ago we were dealing with exponential functions. We were graphing them. We were shifting them. Yesterday we were dealing with square root equations and cube root equations. We were shifting them. So today we're going to be dealing with absolute value equations and their graphs. So absolute values have this form. The parent function means non-shifted most basic function. F of x is equal to the absolute value of x. So these absolute value functions look like a sharp V, and here is why. The absolute value means positive distance. So if we plug in a 1, we're going to get 1. If we plug in -1, we're going to get 1. If we plug in -3, we're going to get 3. So the absolute value will take, it means positive distance, so it will always be positive. So everybody, we could just plot a bunch of points for this. So notice my function starts at 0, 0. If I plug in 0, I get the absolute value of 0, 0. If I plug in 1, we get absolute value of 1 is 1. If I plug in -1, the absolute value of -1 is positive 1. So that's why it's up here. If we plug in 2, we get 2. If we plug in the absolute value of -2, we get positive 2. So does everybody see how this graph is working? Absolute value graph. Okay, so a couple things to note about this. Don't they kind of look similar to a quadratic? Yeah, they do, right? They kind of look similar. Isn't a quadratic a U? This is a V, right? Yeah. So remember back in quadratics how I was saying, oh, yours kind of looks like a V, so I need you to round it out more. It was because V's and U's get confused a little bit. So absolute values are sharp V's. Does everybody see it? Now next thing to notice, these have a constant rate of change. When you have that, it's called a slope. Does everybody see how every time we're going up 1 over 1, up 1 over 1, up 1 over 1? Yeah. But with quadratics, that doesn't happen, right? We have an acceleration. Next thing to note. These have a vertex. They have a lowest or highest point, just like quadratics. Does everybody see how 0, 0 of the parent function is our vertex? Then also there's an axis of symmetry. It's on the vertex, right, everybody? Just like with a parabola. Does everybody see how it's symmetric across that axis of symmetry? Okay, yes?
How would it have a highest point, the absolute value of its positive?
This one is, I said, highest or lowest. So this one has a minimum.
You said lowest or highest, but that's implying that there is a maximum. So how does that work?
If there's a negative in front, our absolute value will be upside down. It would make it a max value.
A negative absolute value.
A negative in front.
Oh, yeah.
Yes. Because that would be, the absolute value of negative 2 is 2, right? But then you have a negative in front, so it flips it upside down.
So
We'll see it. You'll see it in just a second. It'll make more sense. Okay. So domain is left and right. Where's our function growing from left to right?
Infinity to infinity.
Isn't it growing this way to negative infinity?
Yes, ma'am.
Isn't it growing this way to positive infinity? Okay, so domain's all real numbers. That's always going to be true for all absolute value functions. They're going to keep growing, growing, growing. Or if they're upside down, growing, growing, growing from left to right. Our range is going to depend on the function. This is a non-shifted parent function, so looking at it, we're starting at 0, right? And we grow to positive infinity. Does everybody see it? Okay. So here is the equation for a shifted absolute value function. Now guess what? We are not learning anything new. The shifting works the same for all functions, just like the past few days we've seen. So we have f of x is equal to a times the absolute value of x minus h plus k. So just like yesterday, anything added in with our x is our shift left and right, and we always go opposite, right? Everybody.
Right.
It's added in with x, that's our shift left and right, we always go opposite. Then anything added on the outside of the function, added on the outside of the function is your shift up and down, and your sign stays the same. That's the same for all functions, right? And then also, the only difference is that our a value is not an acceleration. So yesterday we saw that our a values were accelerations, and in parabolas they're accelerations. But with absolute values, they're slopes. Because they're the same rate of change every time. So it's a slope. We know how to graph slopes. Don't you know how to graph a line? Yeah?
So what happens if there's a negative as a?
It'll flip it upside down.
Okay.
Yep. Okay, so we're going to have a vertex at h comma k, right? So if our vertex originally started at 0, 0, we then shift it here, then here. Won't our vertex be at h comma k? Okay. So our vertex will be at h comma k. Remember, vertex is highest or lowest point on the graph. And then axis of symmetry. Isn't it always going to be at the x value of the vertex? So it'll be right on that vertex, right? Ding, 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 ding. And it'll be symmetric across that. So it'll be x is equal to h. Okay, so here we go. We're going to graph this absolute value function. The first thing you do is determine where's our new starting point. And you determine that by saying, what's my shift left and right, up and down. So we're going to be going right 2 and up 4, right, everybody? Questions on how I got that? So we're going to right from the origin. I go right 2, up 4. Boom, there's my new starting point. Then from there, we're going to graph our slope. So our slope is 1, okay? So our slope's 1. So isn't 1 the same thing as 1 divided by 1?
Yep.
Yeah? And we graph slope as rise over run, right? Change in y over change in x. So when we're going up 1 over 1?
Yep.
So from here, we're going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then it's a sharp V, we know, so up 1 over 1 this way, up 1 over 1. Oops, I didn't mean to do that one. Okay, so then we can draw in our nice sharp V here with a nice pretty slope. Okay, now let me show you something. Let's say you forgot in the future. You saw something like this, you're like, I don't remember if that's a U, a V, a what. You can always graph it in your graphing calculator and see what it looks like, right? So let me show you how to type in, and we can always check our work and check our answers by plugging in X, Y values. But if we want to kind of use a cheating, like quicker way, we know we can type it into our calculator and use the table of values, because that is technically what we're looking at here, right? Okay, so everybody, you go to y equals. Now to get the absolute value keys, you have to go to math, over to num, N-U-M, down to absolute value, which is number 1. So we have the absolute value, and it's x was it x? It was x minus 2 plus 4, right? So I've got to type it in right. So it'll be x minus 2, get out of the absolute values, or close your parentheses depending on if your calculator's newer or older. So you'll close your parentheses around the minus 2, or get out of there, and then hit plus, sorry, was it plus 3 or plus 4? I can't remember now.
-2.
No, we already did that. Plus 4, right? So then you hit graph. Now you can see, oh yeah, my graph looks right. That's awesome. And then you can always check your XY points by doing second table, and instead of looking at the graph, looking at the table of values. So you can check. At 0, was I at 6? At 1, was I at 5? At 2, was I at 4? Well, yeah. Look, at 0, I was at 6. At 1, I was at 5. At 2, I was at 4. Does everybody see how you can check your work?
Yep.
Okay, awesome. So with that being said, I don't need you to draw in your axis of symmetry, but just remember, isn't this where my axis of symmetry is?
Yes.
And so my vertex will be at what point? 2, comma 4. Does everybody see how it's H, comma K? Okay, awesome. Okay, domain, left and right. Where's my function growing from left to right? All real numbers. Good. And then my range is y values. What y value does it start at? Not y-intercept. What's the lowest y value?
4.
4 to positive infinity. It includes 4. Okay, one more example. So we're graphing this one. So your first thing is determine your shifts left and right, up and down. So we're gonna be going left 5. What if that plus 5 was over here on the outside? Wouldn't that be our shift up 5?
Yep.
So be careful. So we're going left 5. Boom. Now we have a slope of -3. So technically we have -3 divided by 1, right? So we go down 3 over 1, down 3 over 1. So from here, down 1, 2, 3, over 1, down 1, 2, 3, over 1. And then down 1, 2, 3, over 1. So Gary, this is the example that you were asking me about, and same with you, Massa. This is where it flips it, that negative flipped it upside down, right? Didn't it? And so that's how we're able to get the negative values, is because the negative is not in the absolute value. Good questions. Okay, so
Shifted function made it like it looked different because the mother function was just the absolute value of x.
right.
And so I was
Right, it's kinda harder to see it.
The absolute value.
True.
But
Good. I'm glad it's all making sense. Okay, domain, left and right. Where's my function growing from left and right? All real numbers. My range is y values. So what y value does it start at? 0, and it's growing to negative infinity. So we've got to put negative infinity first because it's smaller and it included 0, so I need a bracket. Okay, are we good to go? Well, yeah, you're all working, so I guess we are. Okay. So do 1 through 9. When graphing absolute value functions, you do graph a slope, but mathematically, we have to be able to state what's happening to our graph using the correct terminology, so you all need to listen. You will get it wrong on the test if you write slope of 3, okay? So I want you to focus in. We know that this is a slope for absolute values, right? So if it's 1, it's up 1 over 1. If it's 3, it's up 3 over 1, right? If it's -3, we go down 3 over 1. But what we're technically doing here is we're either stretching or compressing our absolute value function. So let's look at this one. We have 3 times the absolute value of x. Do you see how we have no shift left and right, no shift up and down, but we're going up 3 over 1?
Yeah.
Up 3 over 1. Up 3 over 1. Now look, didn't that take our absolute value and stretch it up? Now that will always happen. It'll always stretch it up if your a value is greater than 1. I'm going to say that again. It'll always stretch it up if that a value is greater than 1. Now the reason I say you look at the absolute value of a is because the negative doesn't count. You do not count the negative. So the negative does not make it, so some people will say, oh, well, it's -3, so it's not a stretch, but it is a stretch. You look at the positive value of a. Okay, so then, looking at something like this, 1/4 times the absolute value of x. Wouldn't that slope be up 1 over 4?
Yeah.
Up 1 over 4. Now, everybody look, do you see how it's compressed? It's kind of smushed. You see how it's compressed? That's because our A value was less than 1. 1/4 is less than 1, so that will compress your graph down. So it just makes sense. Now, once again, you always have to look at the absolute value of A. So we're always looking at the positive answer. Now, that's because the negative in front simply reflects your function over the x-axis. So some people will get in the zone and say, oh, but -3 is less than 1. And you said that if it's less than 1, it's a stretch. It's a compression.
Wrong.
Wrong. You look at the absolute value of A. So even if it's -3, as in such, it's still a stretch. Does everybody see how it's still stretched? But it's also a reflection across the x-axis. So that negative in front is just a reflection. So you do not look at the negative to determine if it's a stretch or compression. Does everybody understand that? Yeah. Okay, yes?
So would you write like stretch reflection over it?
Yeah, good question. So this is how you would write it. So that brings me to this example here, okay? So it says, without graphing, identify the vertex, the axis of symmetry, and the transformation from the parent function. So let's go through and determine the vertex. So to determine the vertex, we're going to be going right 2, right, everybody? Right 2, up 3. So wouldn't that be 2, 3? So my axis of symmetry will be at x is equal to 2, right? Won't it be? Ding, 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 ding. Okay, also, now it says in words, describe the transformation from the parent function. So it went right 2, up 3. We've already done that. Now, there's no stretch or compression, because isn't there a 1 there? That's not a stretch or compression. That's the parent function. The parent function had a 1, so there's no stretch or compression, so we're done. Next one, and then this is the one that Brendan was asking me on. Is there a shift left and right?
No.
No, but we are going up 3. So think about that. If you're not shifting left and right, and you go up 3, that's your new starting point. Isn't that 0, 3?
Yep.
So x is equal to 0. Isn't that my axis of symmetry?
Yep.
So then, I would now in words describe the transformation. So this is my answer, up 3. But then we have a reflection over the x, right? Because of the negative. So reflection over x. And also, because 2 is greater than 1, we have a stretch of 2. Good question. So it's a reflection because if there's a negative in front of your A value, that will reflect it, flip it upside down over the x-axis. Okay. So on this one, here we go, last one, then I'm going to let you finish up the front page. Is there a shift left and right? It's right 7, right? And there's no shift up and down. So think about how that would look on an XY chart. Wouldn't that be going this way 7? So that'd be 7, 0, right? So 7, 0 is my vertex. My axis of symmetry is at x is equal to 7. So we're going to right 7. Well, then there's not a reflection, but it is a compression because 1/2 is less than 1. A compression of 1/2. Does everybody understand why it's compression? Isn't a half less than 1? So won't that compress it down? Because once you go 1, up 1 over 2, up 1 over 2, so it's compressing it. Does that make sense, everybody?
I
Yes.
thought you said you only go up 1/2.
No, this is different than yesterday. These are slopes. These aren't accelerations. So up 1 over 2.
But even on 8, it's 1/4.
We went up 1 over 4. Up 1 over 4. Well, those are slopes, right? That's different than yesterday. Accelerations were different.
That's the same as going up 1/4 over 1.
No, if you go up a whole point over 4, that's different than going up a fourth. So you're just graphing a slope with these. Up 1 over 2. Up, but we're not graphing, we didn't have to graph this one. But if we were, we'd go up a full point over 2, up a full point over 2, both ways.
What if the 3x is times inside?
We'll get there. Okay, do I need to do this one?
No.
Are you sure?
Do it.
Oh, yeah, actually.
Okay, so looking at this, we have y is equal to 4 minus 2 square root, sorry, not square roots, I'm thinking about the questions that I'm getting, sorry. So we have y is equal to 4 minus 2 times the absolute value of x minus 3. Can you combine those?
No.
No, right? That's multiplication to that. So don't we just have 4 minus that? So don't we have a plus 4 out here?
Yeah.
So guess what I'm going to do? I'm going to scribble it out right here and write it back here so it's nice and pretty for me. Same thing, because it was addition, we can just put it in the back. Okay, so then from there we're going left 3, up 4, right? So we have our point at negative 3 comma 4, right? Left is negative.
Yep.
So negative 3, 4. X will be equal to negative 3. That's our axis of symmetry. And then from there, we said these shifts, so we're good. But then also, isn't it a reflection on the X? So reflection over X, you've got to be specific. There's such thing as a reflection over the Y. There's a lot of reflections. So reflection over X axis. And then also a stretch, because 2 is greater than 1, so it's a stretch of 2. Yes.
So if that were to be like a negative, that would just still put a reflection.
Yes, good question. So it would just be a reflection on the X
What about a
axis.
stretch?
No stretch or anything, because it's still a 1. Good question. Okay, so you're finishing the front page now, and then we're going to move on, so keep going. If we were graphing the slope of 1/2, let's just say we're at positive 7, right? 1, 2, 3, 6, 7. Right? And then we're going up 1 over 2. And Braylon said, well, isn't that the same thing as going up a half over 1, up a half over 1? And I said, no. But yeah, it does come out the same. I've never thought about it that way. So good point. So that's one way of doing it, but it's just easier for me to think of going up 1 over 2, right? That's just as easy. Everybody? Okay. So I was just correcting myself. I told Braylon he was wrong, but he wasn't wrong. It came out the same. So guys, so I'm going to do all my examples off your worksheet to kind of help lessen the burden of so many problems. But you need to be watching. These are the harder problems. So it does tell us to graph them. I'm not going to make you graph them as long as you can tell me what the transformation is. So to be able to do that, won't we want it in graphing form where we can easily see? Because everything we've seen so far has been in graphing form. Easy to see what the transformation is. Well, if it's not in pretty graphing form, we can manipulate it, change it, not change it, but kind of move it around to our advantage, just kind of like what we were doing yesterday. So everybody look at number 15. We have y is equal to the absolute value of 3 minus x. Now looking at that, it's really hard to determine the shift on that correctly. Because shouldn't we write the x first? Okay, let's rewrite it. So we have y is equal to the absolute value. That's a negative x. So I've got to rewrite it properly. That's negative x. That was a positive 3. Does everybody see how it's the same thing, just reordering it? Now careful. Everything we've seen so far in front of x has been 1, right? So right now, do you see how there's a negative 1? So we're going to fix it. We're going to fix it by factoring out that value that's in front of x. So we have y is equal to, we still have these absolute value signs. We're going to factor out a negative 1. So now you're going to go back through and see what's left in each term. So you factored out a negative 1 here. You factored out a negative 1 here. There's my negative 1, though it doesn't magically disappear, because a lot of you tend to do that. So what's negative x divided by negative 1? X. What's positive 3 divided by negative 1? Negative 3. Does everybody see how I got that far? Now from here, aren't these being multiplied? Yes. So with multiplication, as long as you keep them both in the absolute value, so we really have the absolute value of negative 1 times by the absolute value of x minus 3. I'm going to split them up and individually look at them. So then we would simplify if possible. So we have y is equal to, what is the absolute value of negative 1? 1. So we have 1 times the absolute value of x minus 3. And now isn't it much prettier? Okay. So everybody, there's one of my answers. I've rewritten it in graphing form, all pretty. Now I can easily see my shifts. We're going to be going right 3, guys. Isn't that what's added with x? Is there any shift up and down? Is there any stretch or compression? 1, but is that a stretch or compression? Nope, so we're done, right? Both of those are our answers. Okay, I'm going to do another one. Number 19. So looking at it, once again, I'm just asking you to write the transformation from the parent function. So looking at it, it's quite pretty. It's in pretty much graphing form, but do you see that 3 in front? So let's fix that, because we'd rather have it be 1. So I'm going to just rewrite it. So I'm going to factor out a 3. So then in each term, what's left? If you pull out a 3, then you factor it out a 3. To see what's left in your parentheses, divide each term. So left is x minus 1/3, right? Okay? So x minus 1/3. Now we won't forget about that minus 2 that was up here. It's on the outside though. Is everybody seeing how I'm just rewriting this to my advantage? Now I'm going to split this apart, because we can as long as we don't change anything. We're keeping it the absolute value of 3 times the absolute value of x minus 1/3. And then we won't forget we still have our minus 2. So then we're looking at this. We're like, okay, we're almost there. What is the absolute value of 3? 3. So we have 3 times the absolute value of x minus 1/3 minus 2. And now isn't it in a pretty graphing form, just like we've been seeing? So now we'll describe in words what happened. We went right 1/3, right, everybody? We went down 2. And because of that 3 is greater than 1 and it's being multiplied, that's our a value. So we have a stretch of 3, which we know really technically that's a slope of 3. But just saying it in the mathematical correct way would be saying stretch of 3. Does that make sense, everybody? Okay, one more. Number 21. Now pay close attention, because when people started going, they could not do some of the problems because they did not pay attention. They're like, I already get it, I'm just going to go. Then they couldn't. So we have y is equal to 1/3 times the absolute value of 2x minus 9. Now this 1/3 is okay, right, everybody? We've seen slopes like that before. The only thing I'm looking at that's a problem is that 2 in front of x. So I'm going to fix it. I'm going to ignore 1/3 for a second. Clear for a second, okay? So I'm going to ignore it. I'm just simplifying in the absolute value. So I'm going to pull out a 2. I'm going to factor out a 2. Then divide each term by what you factored out. So then left is x minus 9/2.
Wait, why is that random weird line there?
I crossed out the 2's.
No, to the left of the purple 2.
These are absolute value things. So I'm just still writing them. They do kind of get confusing. So now because they're multiplication, I can split them apart. Once again, I'm ignoring the 1/3 for a second. So I have the absolute value of 2 times by the absolute value of x minus 9/2. Is everybody comfortable? What is the absolute value of 2? 2. So we have 2 times the absolute value of x minus 9/2. Now here's the catch. If you have something multiplied in front and you ignored it, you can't forget it. So we have times by 1/3, right? So then we can just multiply those together. When you multiply fractions, you multiply straight across. So 2 times 1 is 2. So we have 2/3. So we have 2/3. I just multiplied those together. And then we have absolute value of x minus 9/2. And now it's in graphing form. It's easy for me to see. So in words, what happened was I went
Right 9/2.
right 9/2, and then I went no up and down, but didn't I have a compression of 2/3?
Did you add the 2/3 times?
You multiply, because they were multiplied, it was multiplication up here.
And you only do that for the 2.
You're right, because you wouldn't put it inside the absolute value. But we're leaving it in front. If we did distribute it through, we'd distribute it through to both, but we're going to leave it in front, because that's graphing form. Does that make sense? Okay, so we have right 9/2, and then we have a compression because 2/3 is less than 1. A compression of 2/3, which we know that just means slope of up 2 over 3, up 2 over 3, up 2, right? So that compresses it. Does everybody see what we're doing with this? So if we had a negative in front, and we had to start manipulating this, isn't that just like having a -1? We had a negative in front? So won't you just ignore that, just like it ignored the 1/3 clear to the end? Yes, okay? So you have the rest of the time to finish the worksheets. You have around 10 minutes to practice a few of those and check with me.